Okay, we're going to talk about trig identities. And this is going to be a basic little crash course about some of the manipulations that we can do with trig identities. And so we're going to go through this. I'm going to divide it into two parts. So the first part is going to be the basics. A little bit of recollection. Remember, we cannot break the square root. Now remember, this square root comes up over the top here. We can't break that because we're adding. So we can't break it into the square root of x squared plus the square root of 9. So that's something that we need to remember as we go through all this. This cannot be simplified like this. We simply have to leave it as is. We can't simplify it by making it square root of x squared plus square root of 9. That would make our lives too easy. We can only split it up like that when we're multiplying. So that's the first little part. Now, identities. For example, if we said we have x over 4x, we could simplify that to 1 over 4 because it would be the same as saying that times x over x. And so we're simplifying it because we've got a certain relationship here. So any variable that can be put in, we can simplify like that. And so with these trig identities, we're going to try to manipulate them so that we can get some fractions and things like that. Here are some basic trig identities that you need to know. Here's how this happens. If we have 1 over sine of theta, now this little symbol here, it's kind of funny looking. It's theta. The software I was using didn't have a really good looking theta, so those are thetas right there. So the cosecant of theta is equal to 1 over sine theta. And when we're using identities, we are basically changing what's there to try to make it look a little bit different. And so let's think about this in terms of y and x and r. And so sine is really y over r. Remember, SEER, S-Y-R? And so let's think about what this means. If we are dividing by a fraction, it's the same as multiplying by its reciprocal. And so this is going to be 1 times r over y. Well, look at what that means. That's 1 over 1. 1 over 1 times r over y. Well, that's really just equal to r over y. And if you look at your list of trig identities, isn't cosecant really just r over y? And so this is an identity that we can use now. We know we don't have to go through all of it. We can just say that that is basically the same thing. Okay? So this is r over y. Now, if we move down, let's try to do the same thing with the sine. And so we know that this is 1 over r over y, which we know is equal to 1 times y over r, which is equal to 1 over 1 times y over r, which is y over r. You see what we arrive at. And so when we're doing these things, we're really just manipulating what's there and using the basics of what it means, the basis of these trig ratios, to find out what exactly it is that they mean. Okay, so those are a couple of identities that we can use. Here are some more of them, and we could prove each one of them, but we are not going to. Let's remember, of course, that these are thetas here. Okay? And I think you're going to see that there's a delightful little relationship between all of these. And it's going to look something like this. The cosecant of theta is 1 over sine theta, which we just talked about, and the sine of theta is 1 over cosecant theta. See how they go together? Secant is 1 over cosine, and cosine is 1 over secant theta. Cotangent is 1 over tangent theta, and tangent is 1 over cotangent theta. It's a pretty fair bet. If it says memorize these are going to be pretty nifty to have memorized. This is going to help you when you're working in your calculator also because there's no cosecant button. However, you can do 1 divided by the sine of theta and things like that. Okay? Let's look at how this exactly works. If you need to pause, go ahead. For example, this isn't example 1. This is just an example. This is like an IE. So if we have the sine of theta is 5 over 3, then the cosecant of theta is the reciprocal. Right? Because we learned that cosecant of theta is 1 over sine of theta, which was 5 over 3, which we know is equal to 1 over 1 times 3 over 5, which is equal to 3 over 5. Now, look at what that helps us do. We've been manipulating this to say exactly what we want. There was no calculation there. We didn't have to use Pythagorean theorem. We didn't have to use any of those identities right there, except that we knew the one, which was sine theta, is equal to is 1 over cosecant theta. Okay? So that's what we're working with. We're doing things like this where we're just basically flipping things around and giving them a little bit of a different look. That's all identities is. The work with identities is just making it look a little bit different, finding equivalent statements that just look a little bit different, and then you're part of higher mathematics. A couple more reciprocal identities. Tangent of theta is going to be equal to sine theta over cosine theta. Look at how this happens. We're going to recall right here, tangent theta was equal to what? Y over x, right? And so this is what we're going to try to get to. So let's see how this works. Sine theta, which we know is y over r, over cosine theta, so this is y over r, and cosine theta is going to be x over r. And so this is really going to be equal to y over r. Remember, dividing by a fraction is the same as multiplying by the reciprocal, times r over x. Well, from pre-algebra, we remember we can cross cancel like that, so we end up with y over x. Look at what happened there. You see what we came up with? We knew that tangent was y over x, and simply by doing just a tiny little bit of manipulation with the variables, we were able to get what we want. And so if you want to, you can try to do the same thing with cotangent. I'm going to go ahead and go through it right now, because this is going to be cosine theta over sine theta. If you'd like to work ahead, go ahead. Okay, so cosine theta and sine theta are going to go in the fraction here. And what I'm going to end up with is cosine of theta, which is x over r, over sine theta, which is y over r. And we're going to do the same thing here. We're going to have x over r times r over y. We can cross cancel. Okay, so we end up with x over y, which we remember as cotangent of theta. You see how this works, okay? It will take a little bit of practice to get this down, but stick with it. It's okay. It's going to be all right. I'll be here with you every step of the way. Okay, so these identities that we talked about in the previous slide, these 6 here, and then these 2, you certainly need to know. Okay, that's this part here. Okay, you need to know these things, these basics, to be able to operate under these effectively. Okay, so what else can we do with this? We've got a problem here, and we're going to find some trig ratios, but we're going to do it a little bit differently than we've been doing, because what we can do is we can say the essence of what we want can be found without much calculation. And so if we want to find tangent of theta and cotangent of theta, let's recall for a minute. We're going to use the definition. You're going to hear me say that a lot. Let's use the definition. Let's use the essence of what we're talking about here to find what we want. Because tangent of theta, we recall, is sine theta over cosine theta. Okay? And cotangent of theta is cosine theta over sine theta. Okay? Now, what does that mean for us? If I'm going to find the tangent of theta, what can I do? I'm going to take the sine, which is negative 3 over 5, and put it over the cosine, which is 4 over 5. I'm going to simplify. Negative 3 over 5 times the reciprocal, because when I divide by a fraction, it's the same as multiplying by the reciprocal, 5 over 4. And that's going to be equal to, cross divide here, negative 3 over 4. Okay? You see where I got this from? Okay, and so when I'm going to do cotangent, if you want to do it on your own, go ahead and pause. But if not, I'm going to keep going. We're going to go cosine theta over sine theta is equal to 4 over 5 over negative 3 over 5. Okay? And so when we reduce, we're going to have 4 over 5 times negative 5 over 3, because we're multiplying by the reciprocal. The 5's cancel. We get negative 4 over 3. Is this surprising to us? It is not. Because remember how these were the reciprocal identities? Okay? So they should be flipped. They should be flipped over. So that makes sense. That's a way that we can check our work. And some of you are out there thinking, but what about the way that we learned before when we were talking about sine and cosine? It's okay. We'll see how it all relates in the end. All right? Now, let's talk a little bit about notation. We're notational issues. If we say sine squared theta, this is what we mean. We mean the whole sine theta squared. And we write like this, sine squared theta. So if we said the sine of theta is 3 over 5, and we want sine squared theta, we get this, 3 over 5 squared, which we know to be 9 over 25. Okay? So that's what that means. That's a notational issue. It's very important that we understand that distinction. Okay? That's going to be part 1, guys. Please, please, please watch part 2. Learn a little bit more about identities, but that's the basic crash course. We'll see you next time.